Hi guys, this is Mr. Urrego, and today we're going to talk about arc length and central angles. All right, we're going to talk about the formula for the arc length and the central angles. So first of all, my formula is S equals R times theta. But what is each one of them? So let's draw a circle. I think it's a circle, not an egg or something. From the middle of the from the center of the circle to when I touch my circle, that's my radius, and that's the R. It can be given in any dimensions. Yes, so let's draw another radius, okay? And this is another radius from the center to the circle. This piece of my circle, that's my arc, okay? And that's going to be symbolized by the letter S. And now the inside, this angle is called central angle, and it's going to be symbolized by the letter theta. That's a Greek letter. That theta has to be given in radians. Check the previous video that we talk about radians and degrees, okay? Description. So arc length, central angle, radius, and radius, okay? When this happens, so this is how I want to replace. Now let's do one basic one. Let's pretend that this arc length is the same as the radius. If the radius and the arc length and those two are the same, then my central angle is equal to 1 radian. All right, that's basic. Now let's play with this. Let's find the arc length on our first example. Let's find the arc length. In my case, find S. Okay, when they give me a circle and the radius is going to be 5 inches. That's my radius. Okay, and the angle is going to be 90 degrees. But again, I have to keep those angles in terms of pi radians. So 90 degrees as pi is pi over 2. And the question will be, what's my arc length? So S equals R times theta. R can be given in any dimensions or any units, any units. In my case is 5 inches times theta, which is pi over 2 radians. Okay, I don't have to write the word radians. In our case, 5 times pi divided by 2. They're asking me for the arc length. Therefore, I need to give them a number. I don't want to give in terms of pi. Remember, pi is the same as 3.14. Pi is 3.14 if I want to round. If not, it's going to be more decimals. So in my case, 5 pi over 2, 5 pi over 2 is going to give me 7.85. Now, I forgot about the units. Inches, 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 or we just write 7.85 inches. And that's my answer. Now we have this one. They're giving me the central angle, which is 30 degrees. The radius is 18 centimeters. And they're asking me for the arc. Doesn't matter that I have centimeters, inches, meters, yards, feet. It doesn't matter what unit do we have, okay? My final answer will be given in the same units that they're giving me the radius. So in my case, R is 18 centimeters. My angle theta is 30 degrees. But again, can I have degrees? No, I need that in terms of radians. So I have 30 degrees. I'm going to use my conversion unit. Remember, my conversion unit, and let's put it here, pi equals 180 degrees. And that's my conversion unit. So because I want pi, and I have degrees right now, so it's a fraction, and I put 180 degrees on the bottom because I want to cancel degrees with degrees, and then I put pi on the top. 30 times pi divided by 180, we reduce, so this is going to be the same as pi over 6. I cancel the 0, divided by 3 is 1, divided by 3 is 6. So 30 degrees is the same as pi over 6. Let's put that information. Arc length equals R, radius, 18 centimeters, times theta, my angle, my central angle. In my case, is not 30 degrees, it has to be pi over 6. 18 times pi, centimeters, divided by 6. 18 and 6. 18 divided by 6 is 3 pi centimeters. And if I want to have a final answer, let's take our notes. is going to give me 9.42 centimeters. And that's going to be my arc length. Okay? Now let's use the same formula to find, instead of finding the arc length, I can find the radius, or I can find the center angle. Let's do one of those. Now we have this one. Okay, so the question is, find theta, center angle. You see the 9 inches is red, and the arc is red. So that tells you that that's my arc. So this is my arc length. And this 3 inches, because it's inside the circle, that's going to symbolize my radius. So radius, just in case, because there's a lot of drawings that they don't give you the letters, but they put the numbers next to it. Okay, so now I know that this is my arc and this is my radius. My formula is this. So my formula is arc length equals radius times the angle. And the question is, find theta. Find theta. Let's do some algebra. Let's do the theta by itself. Divided by r, divided by r. R cancels, and now I have S over R equals theta. Okay, let's flip this around. So theta is the same as my arc, which is 9 inches, over my radius, which is 3 inches. If you notice, inches and inches cancel out, and 9 divided by 3 is 3. There's no units. I'm talking about theta, my central angle. If there's no units, remember, I have radians, because I don't have to write the radians as the units. Okay, so when the units cancel out and you're talking about an angle, if there's no answer in degrees, that means you have radians in that case. All right, so I have 3 radians. Now, but what's a radian? It's the same thing. Pi equals 180, but that's equal to 3.14. Remember, pi is the same as 3.14. It's the same thing. So if I have 3 radians, this is almost approximate equal to pi radians as my angle. So my central angle is 3 radians, and that will be my answer. Now let's work on another one that we need to find the radius. Now the question is, find the radius. I have the same formula. I'm not changing the formula. So let's bring the formula over here. S equals R times theta. Radius times theta in radians. So the question is R. This is the R by itself. Divided by theta, divided by theta. Theta, theta cancels. R equals S over theta. S, as you can see, I have 5 inches in red. That means that's my arc. So 5 inches is my arc. 5 inches. I'm looking for my radius. Over theta is 150 degrees. Can I have degrees? No. So the first thing that I need to do is change that 150 degrees into pi radians. So let's do it here. 150 degrees times my conversion unit is pi equals to 180. I want to cancel the degrees, so I put a degrees on the bottom so I can cancel degrees, and the other one I put on the top. All right, so I have 150 pi divided by 180. 0, 0 cancels out. Something that goes into 15 and 18. 3. 15 divided by 3, 5 pi. 18 divided by 3 is 6. So 150 degrees is the same as 5 pi over 6. So let's replace it. 5 inches over 5 pi over 6. And now I have this division, okay? Fractions. Divided by 1. Now, how can I divide 2 fractions easily? I take the very first number, which is the 5 inches, times the very last number. So times 5 times 6 is going to give me 30 inches. And the middle values, 1 times 5 pi, goes on the bottom. All right? So if not, we can do the reciprocal of this, which is 6 over 5 pi. Okay? 6 over 5 pi is my reciprocal. And then 5 times 6 is 30, and 5 pi will be on the bottom. Now from here, reduce. And as you can see, I have inches as my final answer. Why? Because I'm looking for the radius. And that makes sense. Inches. 30 divided by 6, 30 divided by 5 is 6 inches over pi. If I divide 6 divided by 3.14, right, I'm going to get approximate equal to 1.91 inches pi is the same as 3.14. So you can plug it back in. Don't forget the units, and that'll be it. Okay guys, don't forget to subscribe to the channel if you haven't done so. Like the video and comment. Help me out to get into the YouTube algorithm. Okay? Our next video, angles in standard position and coterminal angles. I'll see you in the next one. Take care. Bye-bye.